Yeah, Tecto Silicates. See that today, Tecto Silicates. Yeah, today we are going to discussing about the remaining of silicate family structures. We are going to discussing about the philo of Tectosilicates and other miscellaneous minerals what we have missed. Yesterday we discussed about the silicate groups of anisole, cyclo, and dinosilicates. Now the remaining silicate group of such as pillosilicates, tectosilicates, and various other miscellaneous which will be we see here. Pillosilicates which are represented by the mica group of minerals. These are philo means it is look like as a sheet like structure. Tectosilicates are including feldspars, feldspathites, and silica minerals, and other miscellaneous means natrolite, beryl, zircon, spin, kyanite, sylvanite, calcite, barite, chlorite, starolite, serpentine, talc, apatite are explained here. And coming to the phyllosilicates, in a phyllosilicate family, the mica, it was probably it was derived from a Latin, that is a mica word. It's a meaning that is a chain. It's a mica means it's a chain. The minerals of the mica group, which are characterized by the partly morphology and highly perfect, which have a basal cleavage. It's due to the fact that they bear SiO4 layer. It's atomic structure. It is look like as a sheet like a structure, and which they constitute a group of hydrosilicate of aluminum and together with the alkalis and ferro iron, magnesium. Some varieties of contains in a lithium and titanium, and maximum all of the of these group of minerals which contains monoclinic system, as the front and the back A axis is very tilted, less tilted, with a reference to the vertical crystallographic C axis, and the angle between the two these axes among almost 90 degrees. The monoclinic symmetry, it is not distinctly, we cannot able to see particularly. So their forms may be very intimate to those hexagonal system. Micas can be termed pseudo-hexagonal monoclinic, and the following the list of members of a mica group. In a mica group, we know that is muscovite. It's a potassium mica, and very commonly it's known as a white mica. This is it's a white mica, and others. Yeah. The next one, it is a magnesium and iron mica, and it's also known as a brown mica. And another one, it is a flagophyte. And the flagophyte, it is it is association of a magnesium mica, and lepidolite, it's a lithium and potassium. It is association of lithium and potassium mica, and paragonite. Here the paragonite is special for the sodium mica. Paragonite, it is special for a sodium mica. Zinwaldite. This is also a very rare mineral, and it is a composition of lithium and iron mica. Lithium and iron mica. So that here, as per these composition of members with muscovite and biotite, it's very commonly we see in different rocks. Muscovite system. The muscovite, it has a monoclinic system. It is looking into the tabular formation. The cleavage, it is a perfect cleavage, and the chemical composition, it is known as a KAl2AlSi3O10 and OH taken twice. Hydroxides will be there here. And suppose if you can see, it is in a thin section, it is as a transparent, and it has a parallel extension also. It has a parallel extension, and which is occur in a acid igneous rocks such as a granite and pegmatites. It is called as a white mica, and it is useful in electrical industry. Particularly, we can use this is the white mica. It is in electrical industry, like as a condenser material for insulation. And some of material we can use, it's a lamp chimneys, and it's used as a roofing material, and also used in the manufacture of a rubber ties and the lubricants. Biotite. The monoclinic system, tabular formation, same, it is also having a monoclinic system, tabular formation. And the cleavage, it is a perfect cleavage. It's only one direction. And the chemical composition, it is iron oriented. Potassium, iron, magnesium, and same as well AlSi3O10, AlSi3O10 OH taken twice. In a thin section, we can see it is a transclent. The above one, it is a transparent, but it is a transclent. It is looking into the brownish in color. It has a strongly preocrite, and which is occur in a acidic condition. It is intermediate in a rocks. It's also called as a brown mica. It is also called as a brown mica, but economically it is not much importance as a previous. And next one is a Tectosilicates. The Tectosilicates are called as a frame silicates with SiO2 structure. The feldspar, feldspatite, silica minerals are including in this Tectosilicates family. First, we see the feldspars family. Yeah, feldspars. Potash feldspars, yes. In a feldspars family, feldspars are the most abundant of minerals. They're also very important rock forming minerals. The members of these groups, which are closely related into the chemical composition, physical properties, and as well as if we see in a crystal structure. There are aluminosilicates of potassium, sodium, calcium, and barium. The further classified into the three groups. One, it is a potash feldspar. Second one is barium feldspars, and third one is soda lime feldspars or precious feldspars, which form as an isomorphous series. The structure of the feldspar is a three-dimensional network of SiO4 and AlO4 tetrahedron. Their composition, it can be represented by a formula XY4OH. X, it is known as potassium, sodium, calcium, or a barium, and Y, it stands for silica and alumina. Silica and alumina have a ration. It's a ranging from the 3.3:1 to 1:1. The barium feldspars are occurrence, which will be very rare. The barium feldspars, more than 90% of barium, BaAl2Si2OH molecule, it is known as a Celsian. But those with less than 30% of barium molecules, it is called as a halophane. It is called as a halophane. The members of the family we consider here. The first one we see in a first category, potash feldspar. In a potash feldspar, one it is a orthoclase, second one it is a microcline. The crystal system it is a monoclinic, and the microcline crystal system it is a triclinic. Barium feldspars. In a barium feldspars, the top category that is Celsian. It is belongs to the monoclinic system, and the halophane it is belongs to the monoclinic system. Both are the monoclinic system. I have plagioclases. If you see in the plagioclases, albeit a triclinic system. In oligoclase, it is also a triclinic system, and the same. It's also a triclinic system. Labradorite triclinic, bentonite. It's also triclinic. Anorthite, it also belongs to the triclinic. These are all the Sodalite association of feldspars. Feldspars crystallize in monoclinic and triclinic systems, and the colors it is a white, gray, or in a pink. The range in a hardness from 6 to 6.5, and specific gravity it is as a 2.5 to 3.0. The cleaning it is also noticed here. Either it's a simply or repeated. The cleavage present in a two directional here. Two sets of the cleavage will be there, and the cleavage direction it is a in two directional. Orthoclase. The orthoclase it has a monoclinic and massive form. Perfect cleavage that is known as in the Miller index that is a 001. Hardness is a 6, and condition 6. Crocodile to uneven fracture that we will be observed. Fracture, uneven fracture, that is flesh red color. It is look like as a flesh red color. If you can streak on a plate, and we'll get a white border, white streak, vitreous luster. Chemical composition is KAL. KAL Si3OH. Yeah. KAL Si3OH. In thin sections, green polarization color. It's a oblique extension will be seen, and which occurs in a granite, granodiorite, cyanides. Cyanides, and their volcanic equivalents. This it's also occurring in a metamorphic and sedimentary rocks used in a mild abrasives in manufacture of a sanitary ware and porcelain and pottery materials. Microcline. It is a triclinic system, and in the first case, it is a orthoclase. It is a monoclinic system. It is belongs to the triclinic system. Massive and a granular form. The perfect cleavage that is 001 Miller index source. It's also having the uneven fracture. Hardness is 6. Color it look like is a pink, white, gray, or a white streak we will get. The vitreous cluster it is showing the chemical composition is the same. KAL is a 3OH. In thin sections, it is a colorless. Gray polarization colors, oblique intersection. Cross hatch twinning is visible here, or cross hatch twinning is seen. It occurs in all the important igneous rocks and also in sedimentary and metamorphic rocks. Plagioclase. In a plagioclase, the triclinic massive form, distinct cleavage, uneven fracture. The hardness it is showing as a 6, grayish and white color. Color streak, chemical composition it is a NaCaAl, AlSi, Si2OH. In thin sections it is as a colorless, gray polarization color and oblique extension we see. Laminar twinning, we can able to identify the laminar twinning under the microscope, which is occurs in the igneous and metamorphic rocks, and also sometimes we may see in sedimentary also. It is useful in to manufacture the porcelain and potteries. Yeah, felspatite family. There is a lot of similarities between the felspathites and the feldspars. Is there, as per chemical composition, it will be concerned. They are formed in a place of a feldspar when a magma lacks in the silica and proportionately rich in alkalis. Hence, they can be described as a feldspars deficient in silica. They never occur with a free quartz that would result in a reaction with the latter to form feldspars. Their association with the feldspars also is very rare. Lucite and nepheline of this group differ from the orthoclase and biotite albite of a feldspar group respectively only in being deficient in amount of SiO2. They are all Tectosilicates, but structural bondage between the species, it is a relatively less in relation that of a feldspars. Various members of the group are as follows. Lucite. The potassium aluminum silicate. Lucite, it is a potassium aluminum silicate, and sodium aluminum silicate, it is as a sodium aluminum silicate. It is recognized as a nepheline, and concrenite, hydrated silicate of sodium and aluminum with the calcium carbonate. Sodalite. The sodalite is having the sodium aluminum silicate with sodium sulfides. Lazurite. Sodium aluminum silicate with sodium sulfide, and iron. The sodium aluminum silicate with the calcium sulfate, and nocian. Sodium aluminum silicate with the sodium sulfate. Yeah, see here the variation. Sodalite, it has sodalite and lazurite. Both are having the same mineralogical compositions, but when you come into the iron, it's a calcium sulfate, and nocian, it is a sodium sulfate. The KAlSi3O8, in a thin section, if you see the thin section, gray polarization color, oblique extension, it occurs in a granite and granodiorite, the cyanides and their volcanic equivalents, which also occur in metamorphic and sedimentary rocks, used as a mild abrasives and the manufacture of sanitary ware, porcelain, and pottery. What it is? Lucite. Yeah. In a cubic system, sorry. Yeah. In lucite, cubic system, usually it is a topodiohedral crystals, imperfect cleavage. The hardness, it is a 5.526. It is a colorless to white. And if you get a streak on a streak plate, we will get it, that is a colorless streak, vitreous luster, brittle to the conchoidal fracture, and chemical composition, it is a KAlSi2O6. In a thin sections, it will be visible as a euhydral inclusions are seen. Isotropic occurs abundantly in a recent lavas and phenocrysts, but rarely in plutonic igneous rocks, which is used as a manufacturer of alum and potash fertilizer. Nepheline. In nepheline, it is hexagonal and a small prismatic, large grains. Hardness, it is around 6. Colorless are white or yellowish, reddish, colorless streak we find. Vitreous luster. Chemical composition, it is a NaAlSiO4. The lucite, it is a KAlSi2O6. In a nepheline, we see that is a NaAlSiO4. In a thin sections, it is looking as a subhedral parallel extension and gray polarization of a color, and it is occurs in a soda-rich igneous rocks such as a nepheline cyanide and some basaltic. It is useful in a glass industry particularly. Sodalite. The sodalite, it is a cubic system, granular form, poor cleavage. Hardness, it is about 5.5 to 6. Color, maybe it is a white, blue, green, gray, or a pink. We get a colorless streak, vitreous to greasy luster, uneven fracture. Chemical composition is 3 into NaAlSiO4 NaCl. In thin sections, it appears blue and isotropic, and which occurs in a nepheline cyanide. It's used as an ornamental stone. Silica minerals. In a silica minerals, all species which have their chemical composition as SiO2. This is a SiO2, and it is an inclusion under this group. They occur in various forms, like say quartz, tridymite, cryptocrystalline, jasper, flint, chalcedony, opal. These are out of all these, quartz, which is a crystalline form. It is the most abundant mineral. It's occurring as an essential constituent of many rocks of the igneous, sedimentary, and metamorphic culture. The word the quartz, it seems to originate in a Saxon word, that's a quiffledge. The meaning, it's a quartz vein, cross vein of a ore, which during the course of time, it's become as a quartz, and tending ultimately, finally, it is called as a quartz. The other crystalline forms, namely tridymite and cryptocrystalline, are wide occurrence in volcanic rocks. Yeah, among these cryptocrystalline and amorphous forms, Opal, it's only alone in common, but others are very rare. The temperature ranges of stability of various polymorphs of a SiO2. It's vary from species to species. Such variations found even in uh, within the species, the rock species. The silicon oxygen atoms change their positions according to temperature, pressure conditions. Alpha is quartz is stable up to 573 degrees centigrade to 1473 degrees centigrade. And the beta quartz, it is a stable. That's also it is indicating as a 573 degrees, and between that 870 degrees centigrade. The tridimite, it is between the 870 degrees to 1470 degrees, and crystallite from it started 1470 to 1728. So at 1758 means the material, it is going to be melt. And above the temperature of the boiling point, it's liquid into the silica stable. The pressure, it's also influence the inversion of a temperature. Yeah, wait, please 1 minute. Yeah, please wait 1 minute. I'll be back. Yeah. In a silicate minerals, the temperature is very important here. The silicon and oxygen atoms change their positions as per temperature and pressure conditions. Suppose if it is alpha quartz, it is stable up to 573 degrees centigrade to up to 1470 degree centigrade. And beta quartz, it's stable there, 570 degrees centigrade and 870 degrees centigrade. If you see in a thermite, it's a stable between 870 degrees centigrade and 1470 degrees centigrade. Cristobalite, actually, it is going to be started from 1470 degrees centigrade to 1728 degrees centigrade. It's a melting point. And above that temperature till the boiling point, it's a liquid silica, it is stable. The pressure, it should be influenced. The pressure, it is influenced. It is an inversion to the temperature. The tredimite and the chrysobalite, which are not stable, it's beyond 3000 kg per centimeter square and 5000 kg centimeter square. Suppose these minerals which are not present in the plutonic rocks and which are formed under a great pressure. The transformation between the three crystalline forms, it is sluggish due to the which the highest temperature tridymite and the tridymite and cristobalite, which can exist every below their inversion of a temperature. These three members have a low and a higher temperature modifications known as a alpha and beta respectively. We see here classification of forms in silica as follows. One is the crystalline forms, the quartz, tridymite, cristobalite, and second one it is a cryptocrystalline form without water molecules. Then one it is a fibrous and second one it is a granular. In a fibrous material, the chalcedony, and a granular material, it is a flint, jasper, and jet. If we go into the cryptocrystalline hydrous forms of opal, chalcedony, the only amorphous from which is a very rare occurrences in a leachate layerite. Quartz. Quartz, it is a hexagonal, prismatic, granular, or massive form. Cleavage, it is absent here. Hardness, it is a 7. Colorless to white. The colored impurities are colorless streak, the vitreous luster and conchoidal fracture. The chemical composition, it is a SiO2. In a thin section, if you see, this is a looking into the colorless. It has a anhydral grains and the straight away wavy extension or straight extension it has, which is occurs in particularly in sedimentary and igneous and metamorphic rocks also. We use maximum in mostly we use in glass industry, abrasives, building stones, pottery, and etc. and etc. The varieties of a rock quartz, it's a rock crystal, milky quartz, smoky quartz, blue quartz, amethyst, rose quartz, aventurine, jet, cat's eye, tiger's eye. Those are all different types of the quartz. It will be available in the market. Some of the important miscellaneous minerals. If you know that apart from the silicate minerals, there are certain individual minerals which are important to study because of the minerals. It's also acting as a rock forming minerals. These the minerals include here the natrolite, beryl, zircon, spin, kyanite, sillimanite, calcite, corundum, barite, starolite, serpentine, talc, and apatite. The first we see the orthorhombic system of natrolite. It is a prismatic and looking into the fibrous and massive form. It has a perfect cleavage, and that is indicating the cleavage index here, 110. Uneven fracture. Hardness, it's a 5 to 5.5. White or yellow in color. Colorless, or sometimes we see it is in a white streak. vitreous luster. We can able to see there is a vitreous luster. The chemical composition is a Na2Al2Si3O10 2H2O. In a thin section, it will be seen as a euhydral and straight extension which occurs in cavities of a basalt. Next one is a beryl. Beryl it is a hexagonal prismatic form, imperfect cleavage, hardness it is 7 to 8, concordial or it's an uneven fracture. It is looking into the greenish yellow, emerald green, blue, pink or white color. The vitreous luster. Chemical composition, the chemical composition of this one, it's a Be3Al2Si3O6 taken O3 taken 6 times. In a thin sections, it is visible as a colorless, and it's also having the parallel extension, which occur in a granite and pegmatites. The varieties of this one, aquamarine, morganite, emerald, which are used as a gemstone. And next, coming to the zircon. In a zircon, it is a tetragonal and a prismatic form. Conchoidal packet, it has a conchoidal fracture. The hardness, it is a 7.5. And commonly, it is looking to the brown or a reddish in a color. Colorless straight, vitreous to adamine luster. And the chemical composition, we see that is a ZrSiO4, zirconium, ZrSiO4. In thin sections, it is colorless or low pleochroic. It's also having the straight extension. It is occurs in accessory mineral as in a plutonic igneous rock. And there are two gem varieties here. One it is a jargoon and one it is a isnit. And next one it is a speen. Yeah, we see the speen. It will come under the monoclinic system, euhydral form. Distinction in a cleavage, hardness maybe it is a 5 to 6. Generally, it is looking into the brown. It's also in a green yellow in color, white streak, adamantine luster, and chemical composition, it is a CaTiO5. In thin section, the colorless are pinkish or a brownish, yellowish, pleochroic symmetrical extinction, and it occurs in as an accessory mineral in acid and intermediate igneous rocks, and it is in cyst and gneisses. The kyanite, triclinic and triclinic, it is a bladed form. Hardness, it is a 4. It is in one direction and 7 in other directions. Blue, gray, or a green color, white in streak, vitreous or pearly luster. The chemical composition is Al2SiO5. Al2SiO5. In a thin section, we can see this is a tubular formation and a straight extension. Typical mineral of regional metamorphism. And we can use this is in a gem and in the manufacture of refractories, glasses and spark plugs, etc. and etc. Sillimanite. Sillimanite, it will become under the orthorhombic, the large slender clusters. The cleavage, it will be present. That will be as a 0, 1, 0. Yeah, 0, 1, 0. It is a uneven fracture. The hardness, it is showing about 6.5 to 7. And it is looking into the white or a brown yellowish color. Sometimes we may get it's a color as a streak also. Luster, as per luster, it is getting the vitreous luster. The chemical composition, it is as well the same as Al2SiO5. It is showing the prismatic form. It has a parallel extension, and which is occurs in the cystus, gneisses, eclogite, and slates. Where it is used? It is used in the manufacture of the porcelain and refractories. And another one, it is a calcite. Calcite, it will become under the hexagonal It's a look like a robohedral and granular massive formation, piezoelectric and fibrous nodular and statolitic forms. Cleavage, it has a 3 sets of a cleavage, it will be present. Hardness, it is a 3. Colorless, it is a colorless means it looking into the white. We'll get a white streak also. The chemical composition, it is a CaCO. CaCO3. In thin sections, colorless, it's a twinkling is seen. In a symmetrical extension, it is occurred as an important constituent of a sedimentary limestones. And it is useful in a fertilizer, cement industries, and in manufacture bleaching powder, glass, soap, and paper paints. And marble, it is used to construction of a building. In limestone, it is used to as a road metal, and it is also used as a flux and ornamental materials also. And next one, it is a corundum. The hexagonal crystal system, it has barrel-shaped crystals, uneven fracture, cleavage, basement. Hardness is definitely it is a 9. Looking into the brown color and subvitreous cluster. The chemical composition, it is a L2O3. In a thin section, if you see the thin section, usually it is a clear. If color, the color it is look like sometime as a patchy color. The refractive index, it is very high here, and it is an original constituent of alumina in igneous rocks, such as the cyanides, nepheline cyanides, and anorthosites. It is mainly used as abrasive, and some varieties of a corundum like a ruby, sapphire, and emerald are used as a gemstones. And barytes. Barytes, this is a different one. It's it will come under the orthorhombic system. It is looking as a tabular prismatic formation. Cleavage also it's a present. Uneven fracture. Hardness, it's maybe it is a 2.5 to 3.5. Colorless, the streak. It's a white in color. Vitreous, it is vitreous to resinous luster. The chemical composition BaSO4. In thin sections, we can say that is subhedral and straight extension it has. And it's a very important green mineral occurs in associated calcite, quartz, galena, magnetite. It is used particularly to manufacture papers and paints used by oil companies for making for drilling mud. And also it is used in the flux melting of iron and manganese. Chlorite. The chlorite, it is also monoclinic. It's scaly aggregate tabular formation, and the perfect cleavage 0, 0, 1, hardness 2 to 5. And we see it is light in green color when you streak on a plate. And chemical composition, it is a association of magnesium, iron, alumina, silicates. In this section, we see that is in a green color, green pleochroic. In ultra-polarized colors it has, it will be appear as an alteration product of biotite or hornblende pyroxene, etc. and etc. Next one, it is starolite. It will be also come under the orthorhombic prismatic crystals, uneven fracture, and color it's a green, light green, luster vitreous. Chemical composition is it's a iron silicates, FeAl4, Si2O10OH taken twice. In these thin sections, it is yellowish in a color, symmetrical, and it occurs in a particularly metamorphic rocks. Serpentine is a monocline fibrous foliations of massive form, conchoidal fracture. Then it's a reddish and brown, yellow, and white in color. The streak, it is a white. Chemical composition, it is a Mg6Si4O10OH taken twice. In a thin sections, it is looking as a yellow, parallel extensions, and it's occur as an alteration product of pyroxenes. Talc. Talc, it's a hardness 6 of 1. It will become under the monoclinic system. It's a look like as an apple green to white color. The streak, it is a white in color. It is a fairly cluster also. The chemical composition of this one, Mg3 Si4O10OH taken twice. In a thin sections, it is a colorless. It's a parallel to the straight extension, and it results from the alteration of magnesium and rich rocks and minerals. It is an important constituent to talc and stearate. Here coming to the apatite. In a apatite, the hexagonal system, massive form, granular formation, concadile and uneven fracture, hardness it is a 5. Bluish green, so look like it is a bow. Bluish green, violet, yellow color, it will be appearing. The streak, it is in white color. The chemical composition is a Ca5PO4 3 fluorides, that's F, and chloride hydroxide, chlorohydroxide. So yeah, especially it is for especially it is for a fluorite mineral. In a thin sections, we can see it is a straight extinction in the basal sections of a isotrophic, which is occurs at a auxiliary constant of igneous rocks. It is used in the manufacture of the fertilizers. So this is the overall basic study of the mineralogy and crystallography. Okay, now I'm stopping here.